Okay, let's make some more designs in Autodesk Inventor. And here we're focusing on auxiliary views and we're working on this anchor base right here. I'm going to be monitoring this 3D print during our video today, and I'll try to remember to come back to this at the end to show you what I'm printing. All right, so let's get started on this one. This looks to be in all inches, so standard procedure is to go over to maybe US like that. And this one, to be sure, you can do this one so that it is in inches. Let's give ourselves a little bit of space here so we can see some of the information here as we begin our sketch. Now, it makes sense to draw the side view here and extrude it maybe in one or bidirectional. So let's just pick, how about this one? So we'll call that the right view. So maybe that's going to be the right plane. Now to verify that, oh yeah, it's not really labeled that. It's going to be, in this case, the YZ plane. So we'll freeform this, and always recommend kind of starting at the origin as you're doing these things so that you can at least have one less degree of freedom when you get started. I'm going to go up and then over and then up and then over, down at a diagonal like this. It looks like it is lined up here, so that's going to be a constraint. Then going down this direction here seems to go more than just more well past this vertical line and going perpendicular right here. Then coming back to this point somewhere about here and then going back here. All right, I hope I closed that off there. I'm not really sure. It looks like I did actually right there at the end. So, yeah, oh yeah, I guess maybe what I should do is delete that line there since I have one already right here. I'm not so sure if that actually worked. So, what we can do in this case is try to move this point down to here. So that one right there. So that way we have something starting at an origin. And I think I still need to close this off. It doesn't look like it's a completely closed shape just yet. And then to my surprise, it's not purple, and I'm not really sure why that is because it should be showing all of the things that are not defined in my dimensions right here. So let me go see if I can fix that. But before I do, let's save the file, and we're going to save it as part number. And you go into chapter 9. Let's see. Go back one directory, Inventor, make a new folder right here, chapter 9. This part is 9.2 within the chapter. So put that 0.2 right there. Oh, yeah, and also the 9. Okay. Now let's see why it is that this right view is not showing some of the missing objects here. Um, yeah, I wonder why that is actually. So if we look at this sketch right here, yeah, it should be showing us some of the things that are wrong with it if we say edit sketch. So let's see if I can reset that feature. In my last video, we had the same kind of thing up here with the toolbar. I had to reset that. And maybe it has something to do with that as well. I went up here and I selected ribbon appearance, reset ribbon. And that certainly didn't do it in this case, but it did fix my ribbon last time. So I'm going to search on the internet to find a case where we can make sure that these are purple before we to indicate that they're fully defined. Okay, so what I did was I shut down Autodesk Inventor completely and just draw it and then just drew a square, and I'm still not getting the purple line. So I wanted to show you one way that we can maybe reset this is go over to Autodesk Inventor, and there is a reset utility tool right here. So let's try that.
Sure.
All right, and so I'm going to select the version and then hit reset. Then hopefully it will just take us back to something that's going to work. as far as showing the purple lines when we don't have everything defined. We'll see if this is going to be the case. And what I can do also, I'm making a video for this right here. Once this loads up, I'll be able to push it against the sidebar so it only takes up, let's say, 3/4 of the frame. So maybe before I'll do that, let's make sure it's going to work. So if we go over here to new and make a standard file, it should start showing these sketches properly now. Now I can see a blue background, so now it's starting to look a little bit better. I'm feeling better about the color scheme that it's using now. So there is our lesson learned on that one. So coming back, I'm going to pause the video and catch up where I was over here before. Or you could just follow me and do this again if you like. So I'm going to go up like this, then over, then up again. You know what you might do every time you start this is to maybe give a little bit of a distance associated with these moves. That way, it doesn't automatically rescale after the fact. Now, I think this is going to be a 1/4 inch, this first line. So let me try it that way. And so we select right here. It does say inches. So it makes me feel better that I'm in that one. This needs to be a 1/4 of an inch. So I'm going to put 0.25 for that one. And that'll be our first little motion right there, our first little distance rather. And then we're going over like this, and then up, then over, then down to the same level as this one, all the way across here, then back like this. But it does need to line up with that also. I don't know if it's going to let me do that necessarily. But what I can do is just make it really wrong, first of all, and then make them parallel after the fact. That would make them equal, but this is going to make it parallel. All right, had a little bit of an issue with the alignment on that, but let's see if we can convince it that this is going to be in a slightly different place here. So can we move any of these things over? Now, one thing we could probably change is the angle that's down here. So let's see if we can figure out what angle this is. 20 degrees there. Right. Yeah, what is that angle there? All right, looks like it's going to be 30 degrees. So let's go ahead and put that one in place. You can see this one right here is 30 degrees. So if we go with this one right here, with respect to this guy here, then come down this way, it needs to be 30 degrees. Did that make things overlap a little bit better? Sure. Let's keep going with everything. 0.35 right here. Remember that when it does this right here, you want to click when you're on the line, pull it out like that, 0.35. And then for this entire length, again, you want to click again like that, 1.5. So now it's starting to look a little bit better as far as, closer to what we have over here. The angle between this one and this one is 20 degrees, so we can put that in. Oops, got to be careful not to click on the midpoint. So that one needs to be 20 degrees. Now the other distance you see right here is the 0.12, I believe. Yeah, right there. So that's the width of this one. We can zoom way in on that and label that off to the side like they did, 0.12. At this point, it's maybe a good idea to go in and not overstate our confidence in the numbers. So how about just 2 places, probably 0 places on that one. All right, so it's looking real good here. Okay, and so the other dimension, it looks like the one we're missing, it says 1 dimension needed. I believe is going to be this height right there of 75. So sketch dimension right there. I guess maybe off to this side might be okay right there. Does this make it fully constrained? It looks like it is now fully constrained. So we could move this one off a little bit more just to give some clearance to that number there. Looking real good. I'm surprised it's not showing degrees on that one there. I wonder how I messed that one up. Was it by removing the decimal place? Right here, it just says 30. So that's weird. Let's go in here and see if I did anything wrong on that. Units. Maybe just do it like this. Maybe the decimal place, throw it off a little bit. And it's still not showing degrees on that one. So that is a surprise also. Let's see if there's anything else we can say here. Display as values, display as expression. Guess I'll go back to the forums again and look for a reason why that would not be displayed with a degree symbol. It's hard for me to believe, but it looks like it's always been the case where it doesn't show the degree symbol. I guess maybe I'm confusing the case where we're making drawings as opposed to sketches. So we'll pay attention to this once we get to the drawing and see if the degree symbol shows up for us. Now we do want to extrude this distance of 2 inches, and we'll start cutting away on it. So go over to extrude like this, and let's go ahead and extrude that 2 inches. I was just thinking about how we're going to define the shape of it. Like the view that we want right here, that is the correct home position. If we say the front, then that's really what we want for front. And this is really what we want for right. I was just making sure all of that matches up since that's the standards that we're going to use. Now, it looks like everything is in place except for maybe the holes and also the fillets. What we can do on this fillet is just say we want to select one of them and make it 0.25. And so I'm going to orbit back over like that, make sure that one is 0.25. And you see it says times 5, I think, right there. Actually, it says 5x radius 0.25. Okay, now I forgot to do the cut though before this one is done. So that's not really, I guess we're not really ready to do that one just yet. I do notice that there is a cut right over here. Let's see how deep that cut is. What we can do is draw on this surface, new sketch, and do a point-to-point rectangle from here up to over here. And then the only distance we need here is the 1.5 inch. At that point, we can select this shape and go ahead and punch it out. Extrude cut all the way through. Now we can start adding our fillets back. So we want the 0.25 and we need to do it 5 times. So here is 1, and then right there's 2, 3, 4, and 5. That's good. Looking pretty sharp. Then we start to drill the hole. And this is really the view. This hole right here is really the reason why we're going to need an auxiliary view. And we're going to make the auxiliary view from this face over here rather than the front view, as we'll see in a moment. Let's go ahead and draw on the surface though. Sketch on that surface, new sketch. Oh, there it is. Okay. Let's place that circle properly at 0.75 and 1/2 inch. So we will go here to that one, 0.5. And then from here over, right there, 0.75. Then the whole diameter looks to be 0.5. And then we're going to punch it out, extrude cut all the way through. We're also going to make a slot on this surface. So let's start a new sketch there. And let's get our slot tool, which is underneath the rectangle tool. And let's do a center to center slot. Notice how if you hover over it for a long time, it tells you the sequence in which you're supposed to do these things. So you click twice for the centers, and then once you expand out from there, that gives you the radius. And away we go. We'll start drawing on this surface, and we'll start here, go over like that, make sure it's nice and horizontal, like that, and then come out just a little bit. Let's get all this in place. So first of all, we want 0.5 between here and the edge. And I think it says 0.37 from the bottom to here. I'm reading it correctly. The distance between those two is marked as being, let's see, I think they actually have it over here in the center. It's going to be 0.3. And then we have this distance right here as 0.75. Is everything fully constrained on that? Sure is. Let's extrude cut all the way through. That looks good. Now we're ready to save this one and then make sure we make a drawing that has all of these requirements in place. So we've already done this one right here. We're not going to go through and do the model-based dimensions. It says we're not going to bother with that one right there. All right, so let's go ahead and make our D-size paper drawing. So we go to new up here and select the standard IDW file. And it's going to be based on that one. Of course, let's go ahead and put all of these things in place. So let's go down here to the lower right-hand side and go to annotation and select the entire space right here. And then as you'll see down here, it says we have to use all caps because that's the engineering standard. It's not just something that I made up or your author made up. It's really something that is an engineering standard. And I'll try to remember to do that always. Okay, and this font size it wants us to use this one as a standard is highlight and then type 0.175. And you click and it resizes it, but then we want to make it centered and centered. So that's the way we want it to look based on that. Next thing we want to do is call the object anchor base. I'm going to try to start selecting the space down here instead of the entire square, rectangle, rather. And we want to select all, Control A, 0.4, center, center. Okay. Now the other thing is it wants us to tell us that the dimensions are in inches. Now I'm going to just let you decide where to put all of that. You can either put units here and then put it right here. Some folks put it an annotation up here. I wonder if we could just squeeze it in underneath this. It may not be a good fit though. Let's just put it up here on top. And so we will make a little square right there, or just click and make a dot rather there. And how do they say it in their problem? They say dimensions are in inches. Maybe we should say something like that. All dimensions are in inches. All right. I think we can just do it just like they're saying right there. And we'll position it so that it's maybe like above the Stephen F. Austin area. We might even see how it looks below this right there. Okay, so that's that. Then we want to figure out where to place it. So does it look okay right here? Yeah, I guess it looks all right there. So we can just begin to do it right there. And if this takes up too much space, of course, what we can do on this is go something like that and like that. So basically use the 0.1 size for the font. I hope that's what I used. Looks like I used 0.12. I think it said to use 0.1 inch because that's the same font size that we see right over here. All right, as long as we tell the reader or the machinist that that's what we're going to do, is have everything in inches, then hopefully we will actually see the degree symbols there as well. Let's make sure our paper is D-size, so right click and say edit sheet. Make sure it says D-size right here, 22 inches high and 34 inches wide, large sheet of paper. Center up on that and start making the different views that we need. So here you see that we're going to do a front view, an auxiliary view, and a right view, as well as the isometric. So let's get started on that one, as well as adjusting the scale to make sure everything looks right. We'll come back to those instructions in a moment. You know what to do. When we have a drawing, we go over here to place views. We always have one base, and it needs to be the front view. That looks really good. But you can see this is not taking up much space. So let's go to like 3:1. That looks good. We can move it up a little bit, anticipating the lineup over here horizontally. So maybe like that. Okay, and then we click OK, and then we say now it's time for the projected view. So always have just one base view, and then we select this one and we create a projected right view from that. Now, you also have to right click and say create at that point. And then we need to make our isometric view up here. I'm also seeing that, since the face we want to use to make a circle is this one. So we really, and this one's already, facing us, but that one's not facing us. And so if we showed a top view, if I show you what that one is, you're going to find out that that's not really going to be what we're looking for. You see that in this case right here, if I create that, neither one of those are, circles or, arcs that are, the plane of which is facing you. So that's why we don't really want that view. We want to have a projected view instead. So anticipation of that means I'm going to pull this over here so that I can have the projected view coming up and to the left at that point. Okay, and then while we're here, what I'll do is, let's see if I can move this one around like that, is go ahead and make another projected view for the isometric right up here. Now that one is going to be kind of in the way because the projected view is going to be up from here. So we always tend to put the isometric view. How do I get that? There we go. Isometric view is always in the upper right-hand side. Maybe I'll kind of line it up with the right view like that, up and down. And the front view is always into the lower left. That'll be our standard. Perhaps we can have this come in just a little bit this way because our auxiliary view right here needs to be such that we're going off of this face right here. And so we're going off in that direction. And you see how now we have the nice circle, not an ellipse for that. That's why we need this auxiliary view. Let's do a couple of things here before we get too far away from this. Let's right click on this view. Let's say edit the view and let's give it a name. I think AA is going to be good. But what we want to do is click the light bulb to turn on the label. And then we basically want to edit the label so that it doesn't say scale on there. So delete both of those words. And then the datum right here, the view identifier is going to be A. See where it says view identifier there? So A-A. And we're calling this the auxiliary view. And so if we click OK right there, we should see it placed nice and neat right there. We also want to tell it that we're actually looking at that surface edge on. So let's right click on that again. And don't forget to come up here to display options and say definition in base view. So there it is right there. So there's the definition of AA. In this case, it's not technically the base view, but it's the right view, but it's still giving us some indication that it's looking in this direction. And as you can see in the instructions, let's see, that's not it. Is this it? Yeah. it says that we want to have all of these views labeled. And it tells you how to make what I just did there. It says also use the AA reference, go to definition of base view under the display options tab. So it does walk you through those steps. It also talks about a couple of other things here as well. But let's get the views labeled and complete. So select here until it's red around the outside, edit view, and then we're going to label this one right view and make sure you're using all capital letters. Click on the light bulb there to toggle that. So turn on that light bulb so that when you click OK, it appears down here. I forgot to remove the scale because the scale is already down here. We don't really need to have it in that spot. So we can customize it by clicking the pencil and deleting the scale. So the same thing for this one. Isometric. Light bulb. For toggling the view on and off. I'm sorry, the view label on and off. It says view identifier is basically going to be, this means the datum, which is the isometric view there. Okay, did it work? Sure. One more to go. I guess to be consistent, I really should have said isometric view over there. So I'll go back and redo that one. Notice I am putting the word view on each one of these. So view, 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 and why not put view on this one as well? So let's see, was I supposed to click once on that? Oh yeah, right click on this and say edit view. All right, now we can add the dimensions. So our goal is going to be to make sure that we have the same number of dimensions on our drawing as we do on this diagram over here. So at the end, we'll count these up to make sure that all of these are fully represented over there. One thing that should be really clear at the beginning, though, is that the reason why we made the auxiliary view is because of that circle. And so we could start with that one with our annotation and dimension and immediately go right there and just say that that right there is going to be half of an inch. You can zoom in on it to see that indeed it is half an inch. Now, that's the main thing. Now, the other thing here is that we want to make sure that we put center marks and center lines in for all of these holes. Okay, so we're going through each one of these things, making sure I got all of this. I think I'll just have to remember at the end to make sure that I do best fit. All right, so then let's go up here to the center. And that means that for this circle, we want to put a plus sign in there. Let's see, for this one right here, we want to put it right there. For this one and that one, we want those there. Same here on those arcs. And then in order to connect the lines that go across there, as we probably see down here, you see that line that goes all the way across? We need to use this other option up here to the right. If we hover over that one, we see that it says center line bisector. And basically it means select the two lines right here, and then I'll connect it with a bisector. And so, you don't always need those. It looks like it maybe mostly when you have a slot, that's when you want to use it. So there's that one. And then of course, when you're doing the side view of these, this is really the case when you want these right here. So it kind of show that that's not just like some kind of edge on the other side of it. By saying that it's got this center line through there, it's telling you that this is a hole. So these are hidden lines. And if you have this center line there, it's saying, oh yeah, you got a hole there. Okay, so now let's start putting in dimensions. And I think I will just quietly do that one to myself. Let's see. I kind of like the idea of, I'm already talking, of using the center of this one and this one right here to put the half on there like we had on our other drawing. So it does make sense to continue to use this auxiliary view for cases where we're defining the hole dimension, I'm sorry, the diameter, as well as its position. So that's three of them all handled there. We might even be able to put like the fillet on this one. Either we put it here, which seems to be an odd place to put it, or up here. So let's put it up here. And I think it's going to let us edit it. Now, what we want to do is say, this is basically saying, I'm going to use the data from that measurement that you made in the part, and then put in a number in there in a minute, with the R and the 25. And you can say, well, what I want to also do here is you want to do 5x, because we want 5 of these things. So this basically, I think it's supposed to be capital X there. Yeah. I kind of like to put a space in there, just so you can see it like this here. So I need 5 of these. That's the way they had it on their diagram. You notice it's right down there. That's how they had it, except they had a space in theirs. And so that way we don't have to do this one, this one, this one, and that one. It's basically saying you got, 2 of those. I'm sorry, five of those total. And as we go across here, this one seems like it was labeled right here in the center. I'm going to go off to the side so that the numbers are not going to be overlapped. We need to have the position of this as well as the separation distance. Get these lined up like so. And then also the position vertically from the base this time. So it's over here, 0.37. And so it's not 0.375, it's just 0.37. Can we also say that this one right here is 0.25, or is that one at an angle? To tell about that, you kind of just look at your projection and go all the way over there. And you see that we are looking face on at that surface. So it's okay to do this dimension right here. What we should not do, though, is try to dimension this distance right here, because that's going to be a foreshortened distance. This is a slant right here. So it's going to be accurate, but not intuitive to the viewer. We need to leave it like this to show that this is a piece that's coming out from that. All right, what else do we need on here? Do I have everything? How about the width of the part? Where would you put the width of the part? You could do it over here. But it looks like this one is flat up against the back, so it kind of makes sense to go back and go from edge to edge and just have this hovering above the other two along that axis. And that's how it is also in the view that we see right here. All right, let's see if there's anything else we're missing. Probably some angles, right? So now we get back to that case where it's going to tell us whether or not the degrees are going to show up in this diagram. All right, so really all you really want on the auxiliary view is just the hole in its position. And then this one, it basically has everything in this front-facing view except for the auxiliary view stuff. Now let's put all these dimensions over here as well. So zooming in on that one, maybe going like this and mimicking what we see over there. So remember to go like this, and it's going to be 0.35. So we can now pull it out a little bit after the fact, if it'll let me. Seems like it still wants to edit it. Okay, maybe hit escape, pull it down. Okay, yeah. I have to be out of the edit mode of that, I suppose. We need to have a 1.5 distance from this back corner to this corner. Not like this, but like this right here. You can see that the right view word is kind of getting in the way. So we don't want to have overlapping text, so we can move that down. Looking at the other dimension, that would be the angle in it's 30 degrees. And notice how they put the degree symbol not inside of here like that, but off to the side like, well, I guess like this here. So once you place it and then get out of dimension mode, you could then pull it to the outside, but it looks like it's just going to change it to 150 if we're not careful about how far we move that. Let's go back in here. I guess we'll just leave it just like that. Let's go ahead and put our 20-degree angle between these two planes. And you see the degree symbol is indeed in there now. So I guess it's just not showing up on the sketch view for the part, but it is showing up elsewhere in the drawing. So there's that. Click OK, hit escape, and we can move it to this side, just like we have there. Now, if we count up everything here, 1, 2, 3, 4, 5. And over here, we got 1, 2, 3, 4, 5. And then over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so going back over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what did I forget? It looks like I forgot the height that's right here. So let me do that one next. All the way out like that, 0.75. And then let's count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Got 12 this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we still missing one? Let's see. Got that one in there, got those in there. Okay, I can see it now. It's the width of this one right here. And it may make sense actually to put it over here instead. So counting them up did actually pay off in this case. It helped us not miss that one down here. So I do recommend counting the dimensions to make sure you have it fully described so that when a machinist starts to make this part, you'll be golden. Won't need to have any extra instructions. Let's zoom in on that and see how good it looks. Looks professional, well done. And we'll check out everything that we have in our list. I think we have everything under control. I'll go back and put those numbers in for this one. I guess we can do that now. Okay, so let's see how many dimensions we had right there. 1, 2, 3, 4, 5. So make sure you have 5 dimensions on the right view. And so 5 here, 4 there. And how many did we have over here again? Is it 7? There are 8. 1, 2, 3, 4, 5, 6, 7, 8. That's right, because we had 8 plus the 4 giving us the 12 that we saw in our diagram over here. That looks good. We've completed that. Let me save this. All right, so the next thing we want to do is print this to a PDF file. And of course, the thing we want to be careful with is, and this is important, hit the best fit. Otherwise, everything will get cropped off and I'll only get like a small view of what your work it looks like. So then go ahead and print this to a file. I'll put it on the desktop. Where'd it go? Oh, wait, it went to my printer. I was supposed to print it to a PDF file. Okay, so yeah, I went over to my printer. I'm wondering what that's going to look like. So there's PDF. And then we can save that in the chapter 9 directory as parts 9.2. And it needs to be PDF. I'll recommend always taking a look at these before you commit to uploading them to make sure that they're not cropped off. So I'm looking at the Inventor directory on another screen, and I'm going to pull up the diagram that I plan to turn in, and there it is. And if you zoom in, you can see that the font sizes and clarity are really good, especially considering the fact that this is going to be a large sheet of paper, 22 inches high, 34 inches long, but we are shrinking it down to 8.5 by 11, just so that it's doable on the printers that we have, unless we want to use like a blueprint printer as well. All right, so make sure you upload that file and you should be good to go. I will see you in the next video.